If you guys turn to page 171, we'll do a couple of exercises, which is, we'll start with exercise or example 4.26. And it says, based on weather data collected and raised in Wisconsin on Christmas Day, the weather had the following distribution. We had the event and we had the relative frequency. And the event, if it is clear and dry, there's a 20% chance of that occurring. Cloudy and dry, there's a 30% of chance of that occurring. If there's rain, there's a 40% chance of that occurring. If there's snow, there's a 10% chance of that occurring. Part A. Part A says, based on this data, what is the probability that next Christmas will be dry? So the probability that the next Christmas will be dry, we look back at the table itself and we look that there's a 20% chance of being clear and dry, and there's a 30% chance of being cloudy and dry. So basically we have 20 plus 30, so we have a 50% chance of the weather being dry. So we have a 50% chance of weather being dry. Then we have the second question, which is B, which is based on the data, what is the probability that the next Christmas will be rainy or cloudy and dry? So either rainy or cloudy and dry. So we have a 40% chance of being either rain, or we have cloudy and dry, we have a 20% chance. So we have together a 60% chance of either being one or the other. And then we have part C, says, supposing next Christmas is dry, determining the probability that it will also be cloudy. So determine the probability. So if dry, it will also be cloudy. Cloudy and dry, there's a 30% of that happening. 30% chance of that happening. The next question that we will do is, let's do question number 4.30. So let's do example 4.30. It is a little bit long, but we'll go with it. It says, Micron Technology has sales offices located in 4 cities. We have Dallas, Seattle, Boston, and Los Angeles. It says, an analysis of the company's accounts receivables reveals that the number of overdue invoices by days is shown here. We have days overdue, we have Dallas, Seattle, Boston, and Los Angeles. We have under 30 days, we have 30 to 60 days, we have 61 to 90 days, and we have over 90 days. It says, assume these invoices are stored and managed from a central database. What is the probability that a randomly selected invoice from the database is from Boston sales office? And so then what we do is we literally add all of the Boston and we say we have 198 plus we have 76 plus we have 55 plus 45, we have 374. So Boston would have 374. Alright, so we have the total number of outcomes would be, the total amount of outcomes would be 137 plus 85 plus 33 plus 18 plus 122 plus 46 plus 27 plus 32 plus 198 plus 76 plus 55 plus 45 plus 287 plus 109 plus 48 plus 66. We have our total amount of observation was 1,384. So the probability of database is from Boston or from the sales office would be 374 divided by 1384, which would be 27.2%, 0.02%. So it would be 27.02%. It says, what is the probability that a randomly selected invoice from the data is between 30 and 90 days? So if it is between 30 and 90 days, we would have 30 and 90 days, we would have 85 plus 46 plus 76 plus 109 plus 33 plus 27 plus 55 plus 48. We have 479, which is divided by 1,384. We have 34.70% chance of a database have randomly selected between 30 and 90 days. Then part C is what is the probability that a randomly selected invoice from the database is over 90 days old and from the Seattle office. So over 90 days old and from the Seattle office would be 32. Let's bring up the calculator again. We have 32 divided by 1,384, which is 0.023, so we have 2.31%. The 2.31% chance of it being from Seattle and over 90 days. And then part D, let's see if we are going to do that one. It says if a randomly selected invoice is from Los Angeles office, what is the probability that it is 60 or fewer days overdue? So is from Los Angeles, 60 or fewer days, so we have 109 plus 287. So we have 109 plus 287 divided by, and then it says divided by the total amount of Los Angeles, not the total amount of outcomes, just Los Angeles itself. So we have divided by 396 divided by the total amount. So 396, do not forget that number. So we have 287 plus 109 plus 48 plus 66. So that'd be divided by 510. So we would have 287 plus 109 divided by 510. There will be a 77.65% chance, 77.65% chance that it will be from it will be overdue less than 60 days in the Los Angeles area. Okay, let's do the next question we're going to do is we're going to do question 4.27, and it says the Jack in the Box franchise in Bangor, Maine has determined that the chance a customer will order a soft drink is 0.90, which is 90%. It says the probability that the customer will order a hamburger is 0.60, which is 60%. The probability of a customer will order french fries is 50, which is 50%. 0.50, which is 50%. It says if a customer places an order, what is the probability that the order will include a soft drink and no fries? If these two events are independent, whenever two events are independent, we multiply those events. So this would be example 4.27. And I know we're going back and forth, but it's just for simplistic reasons. I don't want to jump from one thing to another without dealing with this. Alright, so what is the probability that the order will include a soft drink and no fries, and if these two events are independent? Part A says, if a customer places an order, what is the probability that it will include a soft drink and no fries if these two events are independent? Now, the probability of ordering a soft drink is 90%, 0.90, which is given in the directions. The probability of ordering no fries is 1 minus the probability of ordering fries, which is given as 50%. So technically it would be 0.50 or 50%. So part A would be 0.9 times 0.5, which is equal to 0.45. Which is equal to 45%. So there's a 45% chance that the order will include a soft drink and no fries if these two events are independent. So anytime the events are independent, you have to do multiplication. The second question, which is part B of the same one, says the restaurant has also determined that if a customer orders a hamburger, the probability the customer will also order fries is 80%. Determine the probability that the order will include a hamburger and fries. Now keep in mind the directions given where it tells you that the chance of a customer will order a soft drink is 90%. The probability the customer will order a hamburger is 60%, and French fries is 50%. These are independent choices that they make. But if a person orders a hamburger, it's basically a compliment. There's an 80% chance that they will also order fries. But you have to figure out what is the chance, what is the probability that they will order a hamburger and fries, if there's an 80% of them choosing fries. So then you turn to page 168, which is the Bayes theorem. Now the Bayes theorem basically determines what is the probability of two events occurring, being independent but not being independent when it comes to complements. So the probability of experiment or one happening, which would be the very first equation 4.9, which is the second paragraph, is 0.80%. And then the probability of ordering a hamburger, which would be the denominator in that equation, is 60%. 0.60. You cross multiply 0.60 times 0.80, which gives you 0.48 or 48% chance that a person will order a hamburger and fries as well. Now you could have just multiplied 0.80 times 0.60 and you still would have gotten the same exact answer. Or you could use the Bayes theorem equation as well on page 168 as well.